Sum and difference rules. Now in this video, I'm only going to provide you some identities in trigonometry, and as the name suggests, I will be looking at sum and difference of angles, the trig functions of them. So I'll be talking about sine of a plus b, cos of a plus b, and tan of a plus b. A and b are angles. So a plus b is an angle, and we want to know how to write sine of that angle, which is the sum of a and b. And similarly, we can talk about the difference. Now, in this video, there won't be any proofs. So if you're looking for some mathematical rigor, I apologize. You're not going to find anything in here. I'll just give you the formulas, and a lot of times that's all you need to know. But the other thing is you want to remember it for its own sake. And the other reason you want to remember is because this provides the starting point for a host of other trigonometric identities. So let's get into the formulas. Now, sine of a plus b, first of all, let me tell you, this is not equal to sine a plus sine b. So sine is a function. If it takes an angle a plus b, then it's not the same as sine a plus sine b. So you can't distribute that. Now, what is the formula then? What is it equal to? Well, you actually need the help of both sine and cosine. So let me write that down. Sine of a plus b is, I want to write sine a cos b plus cos a sine b. So let's write that. Sine of a plus b is sine a cos b plus cos a sine b. Now, once you know sine of a plus b, so it has, let's actually spend a few seconds on this identity. If you have to find sine of the sum of an angle, then you have two terms, and each term has two factors. So in the first term, I have sine a cos b. In the second term, I have cos a sine b. So notice sine a cos a goes with sine in the first, and b goes with cos, and then they switch. A goes with cos in the second, and b goes with sine. So if you remember that, then you automatically know the formula for sine of a minus b. And again, it's not sine a minus sine b. Well, if you know this, then sine of a minus b looks very much like sine of a plus b, but now the plus will be changed to a minus. So that's the formula for sine of a minus b. Now, you don't have to memorize this. If you remember this, then you can get this. So let me not put that in a box. So that's for sine of a plus b. Now let's move on to cos of a plus b. And you might have guessed that it's not cos a plus cos b. And what would cos of a plus b is? Let me tell you, it does not look anything like sine of a plus b formula. So this is what it looks like. If it is cos of a plus b, then it's cos a cos b. Notice, I don't have sine and cos in the same term, but it's starting with cos a and again cos b. So I have cos and cos again. And here is one other change. For cos of a plus b, I'm actually going to have minus in my formula. So cos of a plus b is cos a cos b minus sine a sine b. So that's what I was trying to say. It does not look anything like sine of a plus b. Sine of a plus b, if there was a plus, you had a plus here. If it's a minus, you have a minus. Now, if you know this, then you can write cos of a minus b formula. So this time it's cos a cos b, and if you have a minus here, you're going to have a plus. sine A sine B. Now, the way I try to remember is, if you think about cosine, it actually decreases in the first quadrant. It's a decreasing function. So if you have a higher angle, then you're going to have a smaller value for the cosine of that higher angle. See, cosine 0 is actually 1, but if the angle increases to 90 degrees, cosine 90 becomes 0. So it's going down from 1 to 0 if the angle increases. So larger angle means smaller value, and A minus B is smaller angle means larger value. Again, there's no mathematics in it, it's just a way to remember. And now let me write down the identity for tan of A plus B. If you have to do tan of A plus B, then it's a fraction. So unlike sine of A plus B and cos of A plus B, where it was not a fraction, there was no numerator or denominator. Here, it's going to be a fraction. And the numerator looks like you're distributing the tan. So you're going to have tan A plus tan B. That's the numerator. And in the denominator, you're going to have 1 minus tan A tan B. And again, I'm not telling you why, but I'm just asking you to remember this because you're going to need to use this in problems, or it also provides a starting point for other identities. For example, in another video, I'll talk about double angle formula, where I will say sine 2 theta, and there A and B, I will replace them with thetas, and then it modifies appropriately. So we'll do that in a separate video. But if you remember this, then that video will make so much more sense. So now, tan of A plus B is tan A plus tan B divided by 1 minus tan A tan B. Now, if I know tan of A plus B, then tan of A minus B is again going to be very much like tan of A plus B, and just like in previous formulas, the pluses will change to minus and minus will change to plus. So again, you can think of this as distribution. It looks like you're distributing tan in there. I mean, that's not exactly what you're doing, but just for the sake of remembering. So it's the plus changes to minus, and this minus in the denominator will change to plus. So 1 plus tan A tan B. So now let's go ahead and summarize the sum formulas. So let me just write down just those three identities. Sine of A plus B is sine A cos B plus cos A sine B. A and B are angle. Sometimes you might see people using U and V or X and Y or alpha, beta. It does not matter. That's the formula. Cos of A plus B equals cos A cos B minus sine A sine B. So let's put that also in a box. And then finally, tan of A plus B is a fraction with numerator tan A plus tan B and denominator 1 minus tan A tan B. Alright, that's it for this video. I'll see you in another one. Thank you.